Okay, hello everyone. So if you have any questions regarding the first lecture, you can ask. So any question? I hope you can easily understand what is a database right now, right? So in this course, we simply have to collect data, and then by using Dbms, which is a software, we have to just store it, manage it, or we will be using SQL language to query that data. Okay, so it's very simple. It's not a difficult concept in computer science or in business informatics. So in this course we only have to manage data, and obviously we will discuss. All of you know that like advantages of storing data on the computer as compared to the on manually or even on Excel file. What do you think? If you have to store data on Excel file, and would it be much better than Dbms or not? Can anyone tell? Are you keeping any sort of data, your budget, your cost of living at Galway or something? Your bills? Nothing? Okay, good, good. So, yeah. When you would be in your practical life, then you would be taking care of much like bills and all payable thing. But you know that we are storing data everywhere, like for any store or for any hotel. You have to manage bookings, right? For airline companies, they have to store data for flight bookings and all the stuff. Okay. So if you don't have any question, then we can start, but definitely I would be revising some part from the previous week so that you have fresh information about databases and Dbms thing. So in terms of database, then we will see what is a Dbms. Basically, what is a database? A large integrated collection of data. We talked about this thing that data should be related, right? So it's some sort of mini world in which you have entities, and every entity would have attributes, right? Characteristics that we want to store. And the third important thing is relationship between each entity. Okay, so if there is an entity in which doesn't have any relationship with other entities, then obviously it means that we are storing wrong data in the wrong database, right? Might be we need that data, but it's not a good place if that entity has no relationship with the other entities, at least one entity. Okay, so Dbms or databases basically models a real world enterprise, entities and relationships. In this course we are only so there are only three things: entities, their attributes, and their relationships. Okay, so this is all about databases, and Dbms is just a software which is managing in terms of storage, and then we can query our data by using SQL language, SQL structured query language. Okay, it's very easy. We will learn in this course. So this is Dbms, and then so what's the expectation from a Dbms? That software, we want keep data around. It should be persistent, right? And it should be able to or capable of answering our questions, which we will be doing through SQL. And the third most important thing is we can update data. Like if you write something on your registers or on your notebooks, obviously you can overwrite it somehow, but obviously its updation is not very easy, right? But in computer, in Dbms, we expect that if we want to update any information about any particular entity, then we can easily update it. Any idea, any information that you think about students that you need to update? Address, yeah. Address could be changed, right? So this is the information, like when student is in first year, at any university or at an NUIG, obviously there would be some information, might be his or her phone number could be changed, right? So DBMS should provide some interface, should be able to update this data. And this updation is also through SQL. So we can say that we would be speaking or we would be communicating with DBMS through a language known as SQL, structured query language. Okay, all the relational databases all over the world are using structured query language, and it's very, very easy. Okay. So then we have attributes, right? And each entity would have its own attributes. We can call it features, characteristics. But obviously every entity has so many attributes. Will we collect all the attributes of that entities, or some business requirements would define attributes? What do you say? Yeah. So basically business requirements would define the attributes of a particular entity. Okay, we discussed this thing in the last lecture as well, that let's suppose if you want to register your car for parking permit at NUIG, then obviously NUIG is not concerned about collecting data of how many seats are there or what is the color of your car. The only information, maximum information would be definitely registration number of your car, right? But for some government institution where you have to pay tax, let's say motor tax or something, might be they need some more information. What is the model, right? What is the color, or what is the engine capacity and all. So it means that for NCT or for motor tax or revenue office, the characteristics of collection, the characteristics of the entity of your car would be more, the number of attributes. But for NUIG, it could be only one or two. Okay, so it depends case to case, and our user requirements or business rules would define what are the important characteristics or attributes that we would be saving in a database about any particular entity. So we talked about this thing like students, courses, professors. These are the entities. We will today we will discuss in detail about more entities so that we would be more clear about entities. And attributes of the student's entity could be his name, registration number, right? And the third important thing is relationships. So each entity would have some relation with other entity. Okay. So we have to define it, that like students can take courses. If course is one entity and student is one entity, then it means that there is some relationship between student and course. Okay. And similarly, course would have some relationship with auditorium or classroom entity. It means that student have indirect relationship with a class, like this location. Okay. But it has relationship because student will be taking, just like you, database technologies, and the database technology course would be conducting in that theater or in any auditorium. So we have related entities. That's why we are saying that entities should have some relationship with each other. Okay. Similarly, universities would have staff, and might be staff wouldn't have direct relationship with student entity, but staff is managing departments, or they are cleaning these auditoriums, or they are managing some other task. So as a whole, for the university, these are the related entities. So it must have some relationships with each other, direct or indirect. Okay. Then we talked about relational model, and in relational model we talked about relations. Okay. We also call this thing as table. In Dbms we call this thing as table. So then we have tuples, one row, one record. When you do transaction online, it is a one record, because you know that for particular order you will get an order ID. Might be there would be 20 items in one order, or if you are booking someone's for someone, for some rooms, it could be 3 or 4 rooms, but it would be a one booking, right? It depends. So this sort of thing is tuple. We call this thing as technically tuple, or we can also call it in many books rows, just like Excel row, right? And columns are the attributes of that row, okay? Then we discuss primary keys, and don't worry, we will be discussing these concepts again and again, so that some sort of reinforcement learning, okay? So I will speak again and again. No, don't worry if you don't get all the concepts, but obviously you can ask questions. So we do need primary key. So who will tell what is the purpose of a primary key? Who will tell what is a primary key? Someone from here? Yeah, good. So that we can uniquely identify a single tuple, okay? Like your order ID and someone's order ID would be different, so that they can differentiate what is ordered by John and what is ordered by Jacob or someone, right? So they need some identity, some ID. It could be one attribute, or it could be combination of 2 or 3 attributes. It doesn't matter, okay? But the combination should be distinct, should be unique all over the table, okay, in one table. So this is primary key. And then we also discuss foreign keys. When one entity is relating with another entity, it means that we have to join 2 tables, right? And when we would be using joining and all the stuff, then we have to use a foreign key, which would be, what it means that like one key that would be a primary key in some other table. So it means that we can directly link. For example, like in a course management system, student is one, but obviously you are taking so many courses over the 4-year time, right? So in grades courses, your registration ID would be there. Registration ID, course ID, what was the grade, and the other information could be what was the semester, right? And then obviously I can link from registration ID to your main student ID table, so that I can find some other information like your full name, your address, and other information, right? So just remember that in databases we don't have to write or enter data again and again. This is the biggest advantage of using databases with respect to the manual system. Remember, if you are writing on a register in which you have different columns, you have to write your full name, your registration number again and again whenever you are doing new entries, right? For example, let's suppose I'm at some hotel and doing booking, and customers are coming, right? And customer says, I have visited this hotel for 10 times, but still if I would have manual system, some sort of register, manual register, right? Then I have to write his or her information again and again. His full name, might be passport ID and phone number, right? Or permanent address. But in terms of databases, we don't have to repeat data if it's already present in our databases. That's why we are using primary keys and foreign keys, so that we can link with some other data, okay? So just like if you are issuing some book in the library, you only have to provide your ID, that's it. Name and all the stuff is not needed, because the database is centrally connected. They know that by using registration ID, they can easily find out full name or in which programs you are registered. So this is the biggest advantage of using databases, that you don't have to repeat data again and again. So this problem is also known as a redundancy problem. So databases or Dbms should solve this redundancy. We do need some sort of redundant data sometimes. Obviously, I have to enter my student registration number, but obviously not that much, other than adding all 10 15 fields of information about the student. Okay, so that's why we need foreign keys. So we will be discussing these foreign keys and primary keys later on as well. So we discuss about physical data independence. In database applications, what we do is that we divide our database process into 3 steps, and that's why we call it as physical data independence. Okay, so just like any other software development process or some other management information development process, we know that if we can make a good design, then obviously good documentation, then obviously it would be very easy for the other person to execute it or implement it. Okay, same is the case with databases. That's why we call this terminology physical data independence, that we are dividing our database creation process into 3 steps, and this will provide physical data independence. So the persons or the people who are working on layer 1, top layer, they don't have to take care of second or third layers. Okay, this is data independence. Their design would be totally independent. Okay, they don't have to worry about implementation details. Okay, so application should not need to worry about how data is physically structured and stored, and obviously this Dbms is doing this thing very well. And if you are making some application, you don't have to worry about how it will be stored in a hard disk. Okay, so this is physical data independence. So applications should work with a logical data modeling and declarative query language. This declarative query language is SQL in our case. Okay, so our only concern is that we would have some logical data modeling, which would be the second part. First part is conceptual modeling. Second, we would be starting conceptual modeling today, and then second part is logical data modeling, and the third part is physical data modeling. Okay, so database development process. So we have business information requirements at the top, you can see, and then you have to analyze your requirements. From that requirements, you would be doing conceptual data modeling, and that conceptual data modeling is widely represented by using ERD, Entity Relationship Diagram. Okay, ERD. So in today's lecture, we will see how we can make ERD. So if we have a good design, obviously it would be done after analysis of the business requirements. Then it's very easy to move on to the second step of database design, or we can also call this as logical design. Okay, and the third one is database build or physical modeling. So we have to do this thing by using SQL. So step 1 is conceptual data modeling. ERD should completely capture and accurately model the organization's information needs and support the functions of the businesses. Okay, so this is very important in conceptual data modeling. So have you worked or heard UML diagrams? UML? Anyone? Ever? No? UML. Okay. It's just a object-oriented sort of programming or software engineering concept in which you have to represent your system with the help of some diagrams. Same is the case with ERD. So can anyone tell what is this diagram? Because you have to make this sort of diagrams in your assignments for your project thing, and obviously it would be coming in your final exam as well. So can anyone interpret this diagram? So we have some entities here, right? Which one? Employee and department. Okay, so it means that in this diagram we have 2 entities, and obviously these are the attributes, right? These are the attributes of this particular entity, employee. I will tell you why we are putting static or hash or O or optional, some sort of thing. Okay, we will discuss this thing in today's lecture. So entities, attributes, and these lines are showing relationships. Okay. So what does it mean that each employee assigned to one department? And the relationships are bidirectional. Okay. So each department may have one or more employees. I will tell you how to write this thing, how to read this thing, don't worry about it. But in this diagram, we are very clear about these three things: relationships, entities, and their attributes. Okay. So in the second step, which is logical modeling or logical view, in different books it would be logical view or logical modeling, but according to Oracle it's database design, so don't worry, just step 2. So in which we would be converting this diagram into some sort of tables. Okay, we are defining this thing, this is on paper, and second step is also on the paper. Okay, or on Excel file you can make, or anywhere you can write. So we will convert this ERD into some sort of more technical form, in which we would be saying, okay, what would be the column names, right? Primary keys are there, foreign keys are there, we would be defined. Then column should contain some value or not, or it would be a mandatory, right? Should it contain unique values or not? Okay. So this sort of thing, and the important thing in this step is data type, right? So what is a data type in computer science? What is a data type of any variable? Like, do you have like any programming course so far or no? No? Java? Okay. Okay, but there are some students from hotel management and some other degrees, and obviously they don't have any programming background, right? Or no? Okay. So don't worry. Programming is a nightmare for some of you, but don't worry, we don't have any sort of programming here. Okay. But obviously there would be some concepts from programming. Data type is a concept from programming. In programming, we have to store variables. So variables can store any value, and we have to tell computers, okay, this value would be integer, this value would be string. So this sort of thing, string, integer, numerical, categorical value, this sort of thing is a data type. Okay. So for every attribute, we have to tell or we have to write in this step that, okay, so what would be the data type of full name? String. Obviously, I hope no one would have number name as a 007 or 009 or something, right? It could be some secret code, but obviously name should be in some, right? In some language, it would be string. That's why the data type of name would be string. Similarly, the data type of date of birth would be date, okay? Or if you are storing age, then obviously it would be a integer number, numeric number, in which you are storing 29, 30, 21, okay? So this step is very important, especially in terms of data type, because you have to define, okay, what would be the data type of each attribute in your tables. Then the third step would be building a database. And this would be done by using SQL, okay? We have different commands in which we can use very easy commands to create a table after defining its attributes. So we will see different SQL commands, and it's very easy to define things. So you can see here, like in SQL, we are just simply saying, okay, this is one command. So we are saying create table departments, right? It means that bold letters are basically, these are the keywords of SQL language. And the good thing about SQL is it's case insensitive, okay? you can create in either small or short in capital letter. But here I am writing this in capital so that we can differentiate that these are the keywords of SQL language. This is the simple name of a table. And then we are saying in this table we have 3 attributes: department number, name, LOC, right, location, and its data type. We are saying, okay, varchar variable characters 25 and 30. We will discuss this thing in very, very detail, so don't worry. But you have some idea how SQL would be. So to create a table, you only have to copy paste this code in Dbms interface and just click it, and it will create one table for you. Is it difficult to create a table in a database if you have this code with you? So only you have to copy paste, and obviously the same syntax is true for all tables. If it has 10 or 20 attributes, it doesn't matter. You have to just repeat all the attributes with their correct data types, and then you have to tell some other constraints, primary key and foreign keys, but we will see this thing. Okay, so after building this database, we can simply creating 3 different tables. So artist is one table, artist album is another one, and the album is another one. Okay, and these are the different attributes, and we discussed this thing. This ID is a primary key in this table. That's why it's underlined, just to be sure that we know that. And here in this table, so this is artist album, artist ID and album ID are making primary key. So here we are joining 2 attributes to make a primary key. Okay, so primary key doesn't mean that only one attribute. It could be one or more, but the combination should be unique. Okay, because one artist can release multiple albums in his or her life, but for each album we would be giving one unique ID to that particular artist. Okay, so data modeling. So data modeling is the process of capturing the important concepts and rules that shape a business and depicting them visually on a conceptual model. Okay, so this is data modeling, and we discussed this thing about conceptual model. Basically, the main purpose of conceptual model is to capture functional and informational needs of a business. Okay, so, and is based on current needs, but it may reflect future needs as well. Addresses the needs of a business, what is conceptually ideal, but does not address implementation. So in a first step, we are not talking about implementation. We only have to draw ERD, entity relationship diagram. That would, if that diagram is fine, perfect, it's capturing all the business rules and requirements, then it's very easy to implement physically your database in any Dbms. Okay, so that's why in many companies there would be some people who would be working on conceptual modeling only, and after the conceptual model is finalized, then they would hand over their document to the logical modeling team or physical modeling team so that they can implement it. Okay, so a conceptual model is called an entity relationship model and is usually illustrated using an ERD. Okay, in some books people do use UML diagrams, okay, unified modeling language, but it's fine if you can represent anything that could be easily understandable. That's fine, it doesn't matter. Okay, and even there is no consensus how to draw ERDs. Okay, so the soft boxes that you were seeing in Oracle ERD, in books you would be seeing simple rectangle, so it doesn't matter. Okay, but obviously as a standard we have to follow one standard. So in this course we would be drawing ERD according to the Oracle ERD notations. Okay, but the terminology or relationship things is same. And conceptual model is the result of completing the data modeling process And importance is obviously is that we are documenting the processes. Okay, it's very important. Business rules. For example, there would be some business rule like the salary of an employee cannot be less than, let's say, 20 euro per hour. Let's suppose it's a government policy or something, right? Or it's a some company. So it means that this is a very important business rule whenever you are adding a new employee in your company, right? So this sort of rule or some other rules can be visualized in ERD, so that the implementation people should know and implement all the rules, so that your database should work as correct as the business rules. Okay, so that's why this conceptual modeling is very important. So it also takes into account regulations and laws governing this industry. So we have discussed this thing: students, courses, professors, entities. So we will quickly see what is the purpose of entities now. Okay. So purpose of entities, it is important to learn about entities because they are the things about which we store data, important things. Okay. For example, entities in school management system. Can anyone tell what would be the entities for a primary school management system? And we discussed this thing that management information system without database is nothing. Okay. So so management information system is almost equals to database. If you want to pursue your career in management information systems, then this is the first basic course, because MIS without database is not possible. Okay. So can anyone tell, if you want, for example, one customer just came and say, okay, I have a primary school and I want some management information system or school management system. What would be the entities in school management system? Who will tell? Someone from the front rows. Students, good. What else? Sorry? Teachers, yeah.
Department, management department?
Department we can say that, or courses, right? Because it's a school, so courses would be there, rooms would be there, and obviously we have to store grades or even attendance of students, right? So there could be so many entities, but obviously user business rules or the requirement document would define what are the important entities that you want to store. Okay, so there is no limit in like if you have some open document in which they are saying nothing, but obviously in requirements document you would be restricting some entities. Okay, these are the 5, 6, 10 entities that are important to this business, and then you can ignore some entities that are not required, because you have to make your system according to the requirements of the customer in most of the times. Okay. So purpose of attributes, it is important to learn about attributes because they provide some more specific information about an entity. Attributes help you distinguish between one instance and another by providing greater details of the entity. Okay. So for example, in a restaurant, you need to list the individual items on a customer's order so that you can calculate the bill, obviously, right? If you are purchasing something, you have to store all the items differently so that you can calculate total price of the order. Okay. So this would be done by using attributes. So we have talked about this thing, unique identifiers, just like primary keys. Okay. It is important to learn about unique identifiers because they distinguish one instance of an entity from another. So one of you also said this thing, that so that we can differentiate one tuple with another tuple. Okay. We are different. So that's why we need unique identifiers. And unique identifiers could be any. If you are a student, your registration number would be a unique identifier. If you go to some social service or HSC work thing, then your PPN, PPS, in fact, PPS number would be unique identifier. Or on your passport number is a unique identifier for that particular country, right? Or your country ID card, or some in US SSN and some other numbers are there. Social security number, okay? So example 1, for unique identifiers in a classroom, you need to distinguish between one student and another. When classifying your CD collection, you need to distinguish between one CD and another. Similarly, for transactions, you have to do this. So an entity is something of significance to the business about which data must be known. A name for a set of similar things that you can list, usually a noun. Okay, so we use a noun word to define some entity. Examples: objects, events, people, right? Entities have instances. Okay, an instance is a single occurrence of an entity. You can differentiate between object and instance, right? Student is an entity, and obviously specific one person is instance of that student. Okay, right? So we have examples. So for example, we have an entity named as person, and it could be any, right? William, Emma. Or product type, it could be shoe, it could be jacket, or it could be video games. So these are the instances, right? And we are talking about entities. Obviously in databases, we want to store values of these instances, but that table or the data would be represented as one entity that we want to store information about jobs. And then these jobs could be electrician or IT person or electrical engineer, right? So these are entities and instances. Some entities have many instances, some have few. Right or wrong? Some entities have many instances, but some have few. For example, any guess? Okay, students and faculty. Do you think the number of students at NUIG would be same as number of faculty? Teachers? Obviously no, right? What does it mean? That a student would have more instances than the faculty. Okay. Similarly, might be other example could be players and managers. In a World Cup, there would be a lot of players, but obviously managers would be almost equal to the number of teams, right? Coaches or umpires or referees. Obviously, the referees' data would be very, very less if you compared all the players' data. Okay, so yeah. So entities can be tangible, like we can see person or product, or it could be intangible, skill level. Like if Java is a skill, obviously it's some sort of intangible thing, right? Or it could be an event-based concert or specific class or specific football match, right? So these are the different types of entities. So attributes, we can use attributes for describing an entity, quantifying an entity, right? Or even qualifying an entity, classifying an entity, specifying an entity. So these are the different things that we can use. Students, like if you like for student entity, if there is an attribute status, or you can say that not status, let's say degree. So it means that degree attributes is quantifying that student to BIS program only, to hotel management program only, or Erasmus exchange program only. It means that this attribute is quantifying, right? Restricting, or at least telling us that, okay, these students are not graduate students, these students are not PhD students. So if we want to search all the PhD students at NUIG, we can simply use, okay, if the status of that student is undergraduate or graduate, then we can simply quantify or think. Same is the case with classify. Classify means we can categorize. Let's suppose we can categorize our customers to loyal customers or new customers, old customers. We are classifying it, okay? So with the help of attribute. So you can specify entity. Specify is just like when you are adding age of your customer or someone, it means that you are giving some information about the customer, or address or phone number, right? Describing an entity. An attribute has a single value. This is very important. Don't put all the data in one attribute, okay? If you have multiple data, if you have 5 information about the customer, then you have to put that information in 5 different attributes. Don't put all the information in one attribute, okay? So that's why an attribute has a single value. Example could be, that's why, you know, on many websites, that's why they ask you your house number and street number separately as compared to the city name, county name, right? Even if you know, I can write all the thing in address line, right? My address is this, Galway County, Ireland. But in most of the website, you will see they would be asking address, street address differently, and then there would be a separate box for city, county, and then state or your country, right? So it means that so that user can enter data separately, so that it could be saved separately in different fields, in different attributes. So to ensure an attribute has a single value, okay? So attributes have values. It could be number, it could be character string, it could be date, it could be an image, or even a sound, right? On Facebook, you are sharing different information, and they have to share, they have to store your information separately. It could be a video, it could be an image, right? These are called data types or formats. What is the format or data type of your attribute value? That is very important, okay? And we have only 5-6 data types that are widely or mostly used. There are so many, might be 13 or 18 in Oracle, but 5-6 are more than enough to make a database, make a good database in Oracle. So these are the entities, and few examples. Like for customer, might be we are interested to store full name, family name, age, shoe size, town of residence, email address. These are the different attributes, and these attributes are coming from the business requirements document, okay? So in many cases might be shoe size, university don't need your shoe size, okay? And even for car manufacturing company or something, they don't need your shoe size to store, but might be this customer is from some is a customer of some shoe company, 8, 9, 10, right? So that's why they are storing, they need this attribute shoe size, okay? And for similarly for car, order, job, transaction amount, transaction date, employment contract, what would be the starting date of that contract, and what would be the salary. So these are the important entities and attributes, and obviously we have to define data types of these attributes, and similarly like family name is a character string, and attributes should be or must be single value, okay? It should not contain multiple values. it would make your database very easy to manage. For DBMS, DBMS would like that sort of databases in which you are storing one single value for in a single attribute. Okay. Any question so far? So some attributes have values that constantly change. We call these sort of attributes as volatile attributes, right? If you are asking for age, obviously if someone is 19 today, next year he or she would be 20. It means that you have to store your, or you have to update your field every year. So, but there are some attributes which are known as non-volatile. Obviously they wouldn't be changing. For example, your registration number, as long as you are taking 1 degree at NUIG, wouldn't be changed, right? Similarly, for transactions, your order ID wouldn't be changed, hopefully. Okay, even if it's cancelled, if you cancel your order, that particular order ID wouldn't be issued to some other customer, never. Okay, so it would be something different. So some sort of these, so these attributes are non-volatile. Volatile means changing with the time. Okay, and in the database design, we try to ignore, or we don't want to use volatile attributes. Any idea, if I don't want volatile attribute of age, what could be the attribute that I could store? Good, very good. Yeah, from date of birth, I can compute age at any time. If it's 2021, I would just minus the year from the date of birth, and I can easily calculate age. Okay. So yeah, so these sort of choices are very important. That if given a choice, select the non-volatile attribute. Okay. For example, use birth date instead of age. So any question? Is it difficult? No? Okay. Yeah, it's very easy, but obviously you have to practice. And over the weekend, I will try to summarize my lectures in some sort of cheat sheet. I would provide 1-page summary of my 2 lectures, my 2 weeks lecture, in which you have to just 5, 10 or 15 lines to read, and all the slides would be covered. Okay. So I will try to make some sort of that thing over the weekend, hopefully. Some attributes must contain a value. These are mandatory attributes. For example, is it possible if I am registering one new student, I am not adding his or her name at university level? No. It means that that name is mandatory. That attribute value should be there. But phone number, okay, it's fine if someone does not have some phone number or cell mobile, that's fine. I can leave it blank, right? So this could be optional. So there are some mandatory attributes and some are that could be left null or blank. These are optional attributes. So in the diagram where there is a static with some attribute name, it means that this attribute is mandatory. Okay, you are defining. Okay, you are defining that this attribute must be entered. This value should be entered whenever there is a new data. Okay, and small o represents optional. We will see. So for example, cell phone number is often optional except in mobile or wireless applications. Obviously, if you are using WhatsApp, can you make an account or install WhatsApp without giving your phone number? No. Okay. So see, this is a business rule, is defining which attribute is mandatory, which attribute is not mandatory. Shoe size at university level is not mandatory. Oh, okay. But if you are ordering some shoe from some company, then obviously they will ask what would be the shoe number that you are ordering. Okay. So you have to define size of your jacket. It's medium, large, small. Okay. But in some cases, it could be optional. So we have defined this thing identifiers many times. Employee has a unique identifier. It could be a single attribute or a combination of multiple attributes, and obviously that information would uniquely identify. Similarly, same is the case with the classroom students. All of you have different identifiers, registration number, so that I can see, okay, this person has submitted his or her assignment or not. Okay, so on the basis of your roll number, your registration number, I can identify your marks, I can your exam sheet, right? So we can take a break now. This thing?
Yeah, this one here. Is this like the extent of how complicated it's going to be, or is there other symbols that we need to be aware of, kind of like illustrate something?
Yeah, basically it's a notation, and obviously when the person, especially this is for the person who would be working for logical modeling.
Yeah.
So he will know that what is the meaning of these symbols.
Okay.
And yeah, it's not for common person or any person in the company who doesn't know about databases. But this specific documentation is a person for who can deal with databases. Okay, so this sort of notation, and it's not standard. Like there are so many different standards, but obviously every company would be following one standard. Okay, but the concept behind all standards are same. They have entities. They would mention attributes. They would mention relationships in a similar way. Okay. The only difference would be like someone would be using only simple rectangle instead of this softbox, or in some standard might be someone would be putting one line under the entity name. So that's nothing. So yeah, okay, yeah. So but in relational model, the concept of entities, the concept of attributes and relationships that we are discussing is same in all standards, in all notations. Everyone know, even someone who does not know this notation, if you would be talking or explaining your diagram, you would be easily understand that, okay, in this database we would have these three entities, and they would have different attributes and relationships with each other. Okay, so yeah, so because in a textbook, in some other textbook might be this notation would be different, but relationships, entities, their attributes would be there. Okay. So if you have done with your attendance, then we can start with this thing. Okay. So in the first lecture, I discussed with you about project groups, and because the class size is around 60 and 61 in fact, so I can go with a project group size of 3. Okay, so sorry, where is this? Okay, 3 students in each group, and obviously you have to select one group leader, anyone. Okay, and then group leader will email me group info like names and registration numbers of other students, and please put their email IDs or something in CC as well when you are emailing me. Okay, and try to do this thing by end of this weekend. Okay, and obviously if you find some difficulty in making groups, or might be you have 2 people and you don't know the other third person, then you can simply email me, okay, we are 2, and then I can randomly add third person in your group. Okay, just remember that in real life you don't have options to select your co-workers. Okay, in a company, if manager says this is in your group, you have to work with them. Okay, so by this weekend, please email me your groups, and I would say make a diverse group. It would be a lot of learning for you people as well, like diversity in terms of your degree programs. It's fine if there would be 2 BIS students and 1 would be from hotel management or some Erasmus visitors or something, so that you can learn something differently from the other domains and some other people as well. Okay, so don't try to become from one group, but it's up to you. Okay. So after 1 or 2 weeks, we would be having some more info on projects. So because after making a group, you have to select what you would be making in a system, database system as a group. Okay, so might be you can start thinking, might be it could be hotel management information system, it could be vendors information system, it could be transactional some sort of thing. Any system that you think you can work on it that could be beneficial for you in your career later on. Okay, might be someone can say, okay, I can try for Facebook database or Amazon database. That's fine. Obviously our scope wouldn't be big enough to cover Facebook thing, but still we can make few entities of friends and their post and their all the stuff, or WhatsApp thing. So it would be good if you can come up with a good idea. Challenging one, obviously you would learn a lot, but don't worry about grades, because I would be grading your group projects with very minimum requirements. Okay, so if you have passed or if you have go through that requirements, then it's good if you can try for a good thing. It could be library information system. So just think about different information systems that you want to build later on. Obviously we wouldn't be implementing it in terms of application because we are not getting some because there is no GUI thing in this course, but definitely we would be designing database, we would be providing its logical view, we would be providing its conceptual view, logical view, and we would be implementing in the database, Dbms, writing SQL, populating the values manually and all the stuff. Okay, so so by this weekend, please try to email me your group number, group name. You can name any name to your group, and yeah. So, but if you find any difficulty, and I know you would find, some of you would find some difficulty, especially students who are still not in Ireland, they are sitting in their home countries. Obviously, they would find some difficulty. So if you have 2 people, then obviously I would be adding some random person in your group. Okay, and don't worry if at the end of the report you have to mention that if someone haven't worked on that group anything, even you can email me during the semester as well, but at the end you have to define this thing, that you have to declare this thing that yeah, this is the effort of 3, all of us, or not. If not, obviously then we can penalize that person if it's true. Okay, so any other question, any confusion about this course? No? So let's discuss entity relationship diagram that we saw earlier. So entity relationship diagram is a consistent tool that can be used to represent the data requirements of a business. Okay, so it's just a diagram, it's just a tool to represent our requirements. So regardless the type of the database that is used, and even in the absence of one. Okay, so for conceptual modeling, you don't need to know that this data would be Oracle, or this implementation would be in MySQL or some other databases. Okay, but obviously we are talking about relational databases, so all type of relational databases only, Dbms. Okay, so this is ERD. And what is an entity relationship model? An entity relationship model is a list of all entities and attributes, as well as relationships between the entities that are of importance. And it provides background information such as entity descriptions, data types, and constraints. Note, the model does not require a diagram, but the diagram is typically a useful tool. So this is the answer of your question as well. Like technically we don't need any diagram, but obviously to depict something, to provide some better visualization of our system, it's good to have a diagram of our system, okay? Just like you do system analysis of your different things, okay? So, ER drawing conventions. Now we will see what this softbox means and why we are putting static in front of some attribute and small o in front of some other attributes. So entities are represented by softboxes. Entity names go in the softboxes. Entity names are always singular. Like if students, we are talking about students, but the entity name would be student. Okay? And by default, we know that obviously in a university we would have many students, not one single student. But the entity name would be singular, okay? And written with all capital letters, so that we can quickly identify this thing, okay, this is the entity name, employee, okay? So these are the different entities, 3 different entities: employee, job, and department, okay? So for ERD, 33% part is covered. If you have any question, you can ask. If it's difficult to write or make a softbox and then write entity name, which would be singular and it would be capital, okay? So from the business requirement, you have to firstly identify which would be the important entities that you are going to draw, or you, so then after selecting entities, different entities, you simply have to make or draw entities with softboxes, okay? Attributes are listed under the entity names. Obviously, if one entity has 5 attributes, I would write all the name of the attributes inside the softbox of that particular entity. Mandatory attributes are marked with an asterisk, okay? So these are the mandatory attributes. What does it mean? That when someone would be implementing that database, or even would be making some application on top of that database, he or she would ensure that the data of that particular attribute must be entered. Just like phone numbers for WhatsApp, new client, just like full name if you are flying your tickets, right? So these are the mandatory attributes. And some attributes could be optional, right? And you can see in many web forms, you have seen this thing, that red static after first name or something, right? It means that these are the compulsory or mandatory attributes or data sets that you have to fill. Because when you would submit that data back to the DBMS, DBMS would mind that thing. That DBMS would tell the application, no, this form is not valid. These attributes are compulsory or mandatory to add, okay? You have got like this experience in many on websites, on different websites, when you are signing up or something. Even on Facebook, if you are not entering your username, it will say, no, you have to provide this username, because that DBMS, when I would be querying DBMS would say, no, provide username and password or something, some other, if you are signing up, full name and other mandatory attributes, okay? So mandatory attributes are marked with an asterisk. Optional attributes are marked with a circle O, small o. Okay. Then unique identifiers are marked with a hash sign. This is the third thing. If you are mentioning that thing, that this identifier would become a primary key later on, okay? So in ERD, we don't call primary key, we call it unique identifiers, okay? So this unique identifier would be marked with a hash sign. So this is an example here. So who will tell commission is optional or mandatory in this diagram? Commission field or attribute is optional, and hire date, yeah, mandatory, right? obviously when you are employing someone, how is it possible that you wouldn't be entering his or her hire date, right? It would be some starting date for that particular employee. So that's why first name, last name, hire date and salary for this business case would be mandatory. Might be in some company, you can say that might be that employee would be hired first and then HR will take time to finalize his or her salary. Then it means that for that particular company, salary wouldn't be mandatory, because if you are entering a new employee, adding a salary is compulsory in this case. But for that company, you would say, okay, it's optional. Okay. Same is the case with commission. Might be there are so many employees which wouldn't have any commission. So you cannot have to enter any value for commission. Okay. That's fine if that thing is null or blank. Okay. In computer science or in databases, we don't call blank, we call it null value, because blank is a character and it's not null. Okay. So whenever I'm saying null, it means blank. Okay. But technically we call it null value, having no value. Okay. And obviously 0 is not a null value, just remember that, 0, right? Because it's a known value. I have 0 commission, it means that I know that this employee has 0 commission, right? But if it's empty, it's null, then it's unknown or undeclared or not compulsory. I can say that very easily. But for 0, I cannot say it's defined or not defined. It could be defined as a 0. Okay. So 0 is not a null or blank. So 2 things are done. Entities and attributes. How to represent your entities in a ERD, and then how to represent attributes of each attribute of each entity in a softbox. For mandatory, static. For optional, we have small o, and for unique identifiers we have hash. Okay, and usually we put that attribute which contains hash at top of the attributes list so that we can easily find out that thing. Okay, it's not compulsory, but it's a good practice that you should start entering attribute name which is unique identifier for that particular entity. So relationships in data models represent something of significance or importance to the business and show how entities are related to each other. Relationship related, right? And exist only between entities. Okay, so relationships are not between attributes to attributes. These are between entities to entities. Even there are some recursive relationships. One relationship with the same entity. It could be possible. We will see some example later on. But for simplicity, relationships exist only between entities. Okay, and they are not one-way sort of thing. They are bidirectional. Okay, and we have to name it at both ends because relationships are bidirectional. So obviously we have to give 2 names to one particular relation. Just like father and son has a relationship, but for father, son entity is different and the name of the relationship is different. But for a son, the name of a relation with father is different. Okay, so 2 entities having relationships, they are bidirectional, and each side or each end would have name. Okay, and these relationships are optional. Again, this thing is also here. Okay, so there are no mandatory. There could be mandatory or compulsory relationships, but it could be optional as well. You have to given a choice. Like for example, if I want to store name of my children in NGI databases for some reason, every employee does not have dependents. Okay, so employee has some relationship with the dependent kids, but it's not compulsory for a employee to have kids, then he would become an employee in some company. Okay, it means that the relationship between employee and dependent is optional. It's not compulsory. Until and unless there is a company which says, no, we cannot hire someone who does not have any kid. But, okay, so that's why I'm saying this thing again and again. This whole database design is dependent on your business rules. Okay, so here I am teaching you that there wouldn't be any employee or dependent kids, but then might be in your practical life you saw one company and they say no, only married people can join this company, and then you can come, sir, you said. So it depends, totally 100% dependent on business rules that are defined by the particular company who is making that particular database application. Okay, but in general, employees employers don't ask for kids and other stuff. Landlords might ask that no kids allowed or no pets allowed, but but at least employers shouldn't ask. Okay, so so that's why relationships between two entities could be optional. So optional means it can exist. When we are saying optional, it doesn't mean it will not exist, otherwise there wouldn't be any relationship between two entities. Okay, so when I am saying employee and dependents, this relationship is optional. It means that 0 or more kids. One, it could be 0, it could be 1 or 2 or 10 or any number of kids. Okay. Then there is another thing about cardinality. I will discuss this. So this is the cardinality. Okay. So in relationships, when we are defining relationships, we have to take care of two things: optionality, maybe or must, and the second thing is cardinality. The relationship is one-to-one or one-to-many. Okay. So cardinality is, we will define this optionality and cardinality in more detail in next slides, but optionality is just, okay, this relationship can exist between these two entities. This is optionality, can. But if I say must exist, it means that it should exist. Okay. And the second thing is cardinality. Okay, this relationship could be one, it could exist or not, but what would be the, in quantity, how many instances could be related with other entity? Okay. For example, an example, cardinality. For example, can you tell me two entities that would have relationship one-to-one? Like one instance could relate to other entity only one time.
Student in course.
Yeah, until and unless he is passed. Otherwise, if he is repeating that course, then the two instances offering in semester 2021 and semester 1 of 2022, right? Until and unless university has some policy that if you are failed, you are out. Okay?
I'm talking about registration system, like when students try to register into a course, you know,
Okay.
choose one.
Yeah, but many student controls it. Okay.
No, many students are okay. Many students are okay. We are talking about one student, one instance. Okay. Other option could be like one-to-one. What else? Like country, we have one entity of country name and other entities of cities which are capital of that country. So might be this relationship, capital entity and country entity would be one-to-one. Obviously, no, I think one country would have only one capital, and obviously one capital wouldn't be a capital of 2-3 countries, right? So this sort of relationship is one-to-one. There are so many other relationships like one-to-one in terms of, for example, student entity and there is some PPS number sort of thing, information system. Yeah, or even order ID for order ID, customer for your online orders. That particular order would have only one relation with the customer, with only one customer. It couldn't be related to two customers, right? Right? One customer can make multiple orders, that's fine. Over the time, today, tomorrow, yesterday, it's fine. But that particular order cannot link with the entity two times, only one time, with one customer, right? So this is one-to-one relationship. We will discuss this thing in more detail. So what is optionality in a relationship? Okay. Relationships are either mandatory or optional. Consider the two entities, employee and job. Based on what you know about instances of the entities, you can determine optionality by answering two questions. And must every employee have a job? In other words, this is a mandatory or optional relationship for an employee. Okay. So must every job be assigned to an employee? So we have to define this thing. Might be companies, obviously in companies every job must have some employees to do this thing, but there could be possible all of them have resigned, or you have just created a new job and you are in the hiring process. So that's why you have to explain this thing and you have to mention this thing that this relationship would be optional or mandatory. Okay. What is cardinality in a relationship? Cardinality measures the quantity of something. In a relationship, it determines the degree to which one entity is related to another by answering the question how many. Okay. For example, how many jobs can one employee hold? Usually in one company, if I am running one company, obviously I would assign one job to one employee, right? Yeah, or one employee could be holding only one designation. If I am assistant professor or lecturer, I have only one job in this particular mini world. I'm not talking about taking other job, part-time jobs, no. I'm just talking about NUIG database. In NUIG database, there is only one job for me, but there could be many lecturers. Remember, we discussed this thing that relationships are bidirectional. So we have to define this optionality in either way, in both way. Okay. So for a employee, job is one, but for a job, there could be many lecturers, there could be many employees having a same designation, right? Or no? Usually right, yeah? So how many employees can hold one specific job? One employee only. Usually in most of the companies, one employee cannot hold two jobs in a same company, okay? Or more than employees, right? Or more than one employee. The cardinality of a relationship only answers whether the number is singular or plural, okay? So when I am saying one, if there is something two, then I would say many. So cardinality could be one or many, okay? So it's singular or plural. Like if it's 2, 3, 4, 5, 10, I would say many. Only I would say many, okay? Like I have one business rule that only customer can buy 5 things from my company in his or her whole life, okay? So it means that 5 is okay, but I would say, okay, relationship of this customer with this company is many, okay? We can handle this thing in physically, how we will handle number 5 or limit to get orders, but in ERD, there is only one-to-one relationship or one-to-many relationship, or it could be many-to-many relationship. Okay, we will discuss. So examples are here. Each employee must hold one and only one job. Each job may be held by one or more employees. Each product must be classified by one and only one product type. Okay, these are the different examples. Each product type may classify one or more products. Okay. So, for example, we have a seat like for train or some bus or aeroplane, right? And we have passenger. So it must have some relationship at particular time, right? So each seat may be sold to one or more passengers. Is it possible? Usually airlines do this thing, usually, because they know that 70% of the or 10 or 20% of the passengers wouldn't show up at the right time. So usually if they have 100 seats in the aeroplane, they would sell it to 110 or 120, and they are okay with that. Usually they don't have so much clash. Always they have 2-3 seats extra, and even might be you have I don't know, many times sometimes they say that, okay, I can upgrade your seat, or I can, if you can leave your economy class. So it depends. If you are lucky, they can give you business class for some reason. Okay, or might be they can say you, okay, if you want to stay in Paris for 2 more days, you can go back from the airport and spend 2 more days somewhere else and then come back for this flight. We wouldn't be charging you anything. But usually for trains, obviously, like Irish Rail and all the stuff, each seat would be sold to any passenger. So each passenger may purchase 1 seat for a particular train I'm talking about, okay, and seat is sold to a passenger or passengers, hence overbooking. Obviously, if you are selling your different seats to many passengers, obviously it's overbooking. Okay. So there is some business scenario 1. What are the relationships in the following business scenario? In our restaurant, a customer walks up to the counter and places their order. Customer can order for him or herself only, or for himself or him or herself and others. For example, a mother orders for herself and her children. Okay. So we consider the mother to the customer who owns the order and is responsible for payment. That's why companies have only concern with one person, because that person would be paying order, okay, in any restaurant. Over a period of time, a customer can place as many orders as she wants, talking about mother. So optionality must be or may be. What do you say? For your customers' relationship with the order entity, that thing would be must or may. So each customer must order something. Each customer may order something. What do you say?
Might order something.
Sorry?
Might order something.
Might order something. And obviously, if I'm saying this person as a customer, it means that he or she ordered something. Otherwise, he or she wouldn't be my customer, right? So because otherwise in the customer table I'm not putting 7 billion persons of the world in my customers table, right? I cannot, no need of it. And if I'm quantifying or specifying someone as a customer, it means that in a previous days or in some previous month or something, he or she must have ordered at least one order. That's why I'm calling his or her as a customer, okay? And cardinality, how many orders he or she can place? In normal cases, any number of orders, right? I can purchase anything every day if I have money, right? I can go to any restaurant any day, any number of time, until and unless they are bored of me or something, right? So yeah, so I can go any number of times. So each order must be placed by one and only one customer. We talked about this thing. it's not possible that two customers saying that no, I am ordering this thing. Even if it's a same item, obviously it would be two different orders for two different people. Okay, so one order must be placed by one and only one customer. Each customer must place one or more orders. We talked about this thing. So relationships could be something like this in business scenarios, right? So these are the customers. So customer, they are placing few orders. So here she's putting or placing two orders, one order and one order. That's fine. Okay, one or many. Okay. Any question? A relationship can join one entity to itself. Is it possible? Okay, it's written, but is it possible? It's called recursive relationship. Okay, you like yourself. Okay, so recursive relationship, entity likes same entity. Like employees, for each employee we have managers, but manager is also an employee. Same is the case in NUIG. If we have HOD or dean or some other administrative people who are working with us, they are also an employee of NUIG. Okay, so it means that this sort of relationship is recursive. That entity can make a relationship with the same entity. Okay, but obviously instances would be different, right? Like if I am an employee, I am a lecturer, my HOD would be also employee in the same database of NUIG, but he's my boss. Okay, same is the case with manager or general manager or some other one. Okay, so this sort of relationships in which only we have one entity and it's some sort of recursive, so it could be possible. So each employee may be managed by one and only one employee. Each employee may manage by one or more employees. So then obviously if it's recursive, then we have to define this thing that what would be the cardinality and optionality of the relationship. Okay, two things that we have to define. Relationships are lines that connect entities. These lines are either solid or dashed. These lines terminate in either a single toe or a crow's foot at the end of each entity. So we have discussed this thing that relationships could be optional, but how we can represent optionality and cardinality in ERD, it's talking about this thing. Okay, so you can see, so this is a solid line, right? It means that this is a solid line and this is a dash line, and it means that a relationship from employee side is mandatory, right? Must have, each employee must have some department. Okay, and this crow foot, or if there is no as such single toe or there is as such no line or something, this thing is representing cardinality. Okay, this is for many, this is for one. So in one relationship, technically we have to define 6 things. Okay, 2 names, like each employee works in is a relationship name for employee for department. Okay, and then for department, each department is responsible for 2 names, 2 optionality things, and 2 cardinalities, because we are talking about each directional, in each direction. Okay, so that's why 6 things. So here you can see 6 things, like this solid line is mandatory sort of thing. Okay, each employee must have, and this is optionality thing. Okay, in optionality we have must or may have. This dotted line means may, might be. And for cardinality, if this employee can work but it means that each employee can work in, here there is no symbol as such, single toe, so we will read this as each employee works in one and only one department. Okay, and from this side, each department may, because this is dash line, may be responsible for one or many employees. Okay, so by this way we can read this thing, like we can make a sentence, maybe, must be, one or many, or one and only one. Okay, so can anyone read this relationship between employee and job just like a sentence? Who will read? It's COVID, otherwise I can put some candies and throw candies for a person who would be answering correct, but, or even just answering is fine. Correct is not needed, but just speak. Who will read this relationship between employee and job as a sentence? I can repeat relationship between employee and department again. For example, each employee must works in, must is coming because the line is solid, which is connecting employee relationship. Each employee must works in one and only one department. Who will read for employee towards going job?
Each employee must have one job. Each job may have one or many employees.
Each job may.
Each job may have one or many employees.
Good, perfect, perfect. Okay, so in this diagram we are just saying that each employee must have or must assign to one and only one job. Okay, because there is no crowfoot on the job side, so that's why we are saying one and only. And similarly for job, each job may be assigned, because this is a dashed line, may be assigned to one or many employees, because there is a crowfoot on the employee entity towards job entity. Okay, good. So by this way we have done with ERD. It's not difficult. At home you can try different examples. Definitely in the next class we would start from this thing, that how we can write more ERD, we can make more ERD diagrams, but it's not difficult. So we only have to consider entities, their attributes, then relationships. For each relationship we have to define 6 things, 2 names, 2 cardinality thing, and 2 optionality thing. Okay, we can stop here. We will start this thing in the next class.